Hello, Shagath Unknown here. Welcome to another Rust coding stream here on the 16th of January 2023, local time 10 o'clock, as my watch is reminding me that I just started streaming. Thank you. Alrighty. So I thought I'd open my stream manager, but I didn't. Well, I clicked on something, whatever it was. So let's catch up on where we're at. We're done with the map generation algorithms. We wrapped up there last time. I'm having a problem, which I've just now remembered as I got here. I'll just deal with it for now, but I'm not sure what's up with it. Basically, before I used to be able to expand the size of the window that the game is in. I can't do that anymore. I can't go into the corners of the window and change it. But so we added like doors and stuff recently. We expanded on the corridors and stuff. We did a lot of new map generation stuff here. So we kind of wrapped up that, honestly. Like, there's not really anything else we're going to be doing there. We have, I don't know, like 14, 13 different algorithms, and then a couple different modes for some of those algorithms. And they all implement these cool little traits so they can be used in different stages of map generation. So we get cool things like this here. This would be our Drunkard's Walk algorithm. And now we're doing a wave function collapse on the algorithm. Or on the results of the algorithm. So this kind of shows off what we've been working on more recently. And as I said, we're done with map generation now. Most recently was like this door here. So to the bottom left of my character, now to my bottom. If I move into it, we open the door. We actually have another door there, which happens sometimes. We put very simple rules for how doors are placed. So it would be advisable to put more interesting rules if you so choose. Now, as for the code base, things are a little bit different, and this is actually what led to me not being able to resize the window. After the last session, I went ahead and pulled down a fresh copy of the project. That way I had basically no changes from the original. And I went through and I addressed all of the Clippy all the things that made Clippy a little bit mad. So if we scroll up, it's not showing. But basically I addressed everything that was making Clippy mad, which was usually basic things like, hey, you're making a reference here, which is immediately dereferenced, so you don't need to do that. There were a couple of basic things like that. And I actually went through and replaced some if-lets with let-elses where I thought it was cleaner and better. And a couple of basic things like that. But I didn't see anything readily happening in main that would have changed the way the window is being created. Unless there's something down here that I missed, but no, there's not. Everything up here looked the same with the RLTK builder and everything. Scan lines, all that looked the same to me. And my versions of the crates looked the same. So I'm not 100% sure why I can't resize the window on this version now. I will probably keep looking into it a little bit, but it's just a very bizarre thing to see happening. It's unfortunate because the window's a little bit too small for my taste. But I guess we could. Let me try one thing. Yeah, we'll just leave it on that for now. I'll look into that on the side. So where does that leave us today? If we finished the map generation. Oh, that was the last one I failed to mention. The way we were just moving around with the camera, that was also added with the ability to decouple our map size from screen. So before, our screen was like, okay, we have this many, this many glyphs, this many characters wide it was at 80 by 50, as you could see there in the center of the screen. So our maps were being made with that in mind. And now we've decoupled that. We've got a camera and everything in place. So we can have maps of whatever size we want, which is going to be useful down the road. All right. So now let's move over to the text here and let's see where we're going to go. So we're going to go through like 3 sections here today. And the 2 of them are not really going to be any standard programming or anything. It's going to be me reading. So we'll just breeze through these real quick. But the idea here is that we're making a game. Let's make a game. Well, what have we been doing before? Well, we made a basic framework of a game, and we added a bunch of maps and everything to it, a bunch of different algorithms that we can use, but we can make something that's more of a game. And this first section here is going to be, let's understand what we're even defining as a roguelike. The second section on design document, a DDoc or a design document is basically the most important thing for most game development, because it gets your ideas laid out on paper or on probably not paper today, in a file somewhere. It gets your ideas formally laid out and documented so you can like fine tune and really understand what it is that you're trying to build. And it helps you stay focused and reach that goal. And then we're going to do raw files, data-driven design. Also, I just realized I have a bad notification popping up. That's on me. Let me fix that real quick. My bot timer is telling us this is a story-driven game. It's for Metal Gear Solid. Alrighty, so now we're good there. Okay. So let's just go on and breeze through this and get an understanding of what it is we're trying to do. So far, the tutorials followed 3 sections. So we make a skeletal game, showing how to make a very minimalistic roguelike. We add some essential genre features to the game, making it more fun to play. And we build lots of maps, very important part of making fun roguelikes. Now we're going to start a series of articles that actually makes a cohesive game from our framework. It's not going to be huge, and it's unlikely to challenge for best roguelike ever status, but it will explore the trials and tribulations that go with turning a tech demo into a cohesive game. So yeah, what we've seen here, by the way, our tech demo is also something akin to a vertical slice. Now, not entirely, because generally a vertical slice would have already had some kind of design document, and you would know what it is you're doing. But the idea is a vertical slice is kind of a minimal demonstration of all of the main features and stuff that you want to be in your final product. So it's like, let's kind of, make something, and it's usually kind of hammed together for the sake of that demo. It's not necessarily like the real, like you might still work on it from that point on and make it better. So it's not necessarily the final implementation, but it's enough that it looks good enough that you can attract people's interest. That's the kind of thing that you would see on a early trailer. That's the kind of thing that you would see on a Kickstarter or something. Or that's the kind of thing you would see if you're pitching the idea to somebody for funding or something. So the Berlin interpretation. This game will stick closely to the genre with very little groundbreaking innovation. So it'll have a fantasy setting, dungeon diving, and limited progression. If you're familiar with the Berlin interpretation, an attempt at codifying what counts as a roguelike in a world of games using the name. We'll try to stick closely to the important aspects. So the high value targets for a roguelike, random environment generation is essential. We've already covered a lot of interesting ways to do it. Permadeath defines the genre, so we'll go with that. We'll probably sneak in game saving / loading and look at how to handle non-permadeath if that's what you want, but we'll stick to the principle and its implication that you should be able to beat a roguelike without dying. Turn-based. We'll definitely stick to a turn-based setup, but we'll introduce varying speeds and initiative. Grid-based. We'll definitely stick to a grid-based system. Non-modal. We'll probably break this one by having systems that take you out of your regular all-on-one-screen play system. Complexity. We'll strive for complexity, but try to keep the game playable without being a master's thesis topic. Resource management. We've already got some of that with the hunger clock and consumable items, but we'll definitely want to retain this as a defining trait. Hack and slash, definitely. Exploration and discoverability, absolutely. So our low-value targets are single-player character. We're unlikely to introduce groups in the section, but we might introduce friendly NPCs. Monsters are similar to players. The ECS helps with this since we're simulating the player in the same way as the NPCs. We'll stick to the basic principle. Tactical challenge. Always something to strive for. What good is a game without challenge? ASCII display. We'll be sticking with this, but may find time to introduce graphical tiles later. Dungeons, well, of course. They don't have to be rooms and corridors, but we've worked hard to have good rooms and corridors. Numbers. This one's a little more controversial. Not everyone wants to see a giant wall of math every time they punch a goblin. We'll try for some balance, so there are plenty of numbers mostly visible, but they aren't essential to playing the game. So now, it seems pretty likely that with these constraints, we'll be making a real roguelike, one that checks almost all of the boxes. Our setting? We've already decided on a fantasy faux medieval setting, but that doesn't mean it has to be just like D&D or Tolkien. We'll try and introduce some fun and unique elements in our setting. Narrative. In the next chapter, we'll work on outlining our overall objective in a design document. This will necessarily include some narrative, although roguelikes aren't really known for deep stories. Yeah, I would argue roguelikes are known for more emergent gameplay, emergent narrative. Just the way all the systems and everything fit together builds out a story. And I've actually got a book, it's not in the room with me, but I've got a book on that called Procedural Storytelling in Game Design, edited in part by Tarn Adams of Dwarf Fortress fame, and he has an essay in the book as well. It's very interesting. If you plan to finish a game, it's important to set out your objectives ahead of time. Traditionally, this has taken the form of a design document, a master document outlining the game and smaller sections detailing what you want to accomplish. In this case, it also forms the skeleton of writing this section. There are thousands of online references to writing game design documents. The format really doesn't matter so long as it acts as a guiding light for development and gives you criteria for which you can say that is done. Because this is a tutorial, we're going to make the game design document a skeleton for now and flesh it out as we progress. That leaves some flexibility in writing the guide on my end. So until this section is approaching complete, consider this to be a living document, a perpetual work in progress, being expanded as we go. That's really not how one should write a design document, but I have two luxuries that most teams don't. No time limit and no team members to direct. And me as the reader right now is fighting off a sneeze. Give me a moment. Rusty Roguelike is a 2D traditional roguelike that attempts to capture the essentials of the genre as it has developed since Rogue's release in 1980. Turn-based, tile-based, and centered on an adventurer's descent into a dungeon to retrieve the Amulet of Yala, yet another lost amulet. The adventurer battles through numerous procedurally generated levels to retrieve the amulet, and then must fight their way back to town to win the game. Characters. The player controls one major character, hero protagonist, as he/she/it battles through the dungeon. Human NPCs will range from shopkeepers to fantasy RPG staples such as bandits, brigands, sorcerers, etc. Other characters in the game will largely be fantasy RPG staples: elves, dwarves, gnomes, halflings, orcs, goblins, trolls, ogres, dragons, etc. Description of all NPCs should go here. A stretch goal is to have NPCs belong to factions and allow the clever player to faction farm and adjust loyalties. Ideally, NPC AI should be more intelligent than a rock. Story. This is not a story-heavy game. Roguelikes are frequently shorter in story than traditional RPGs because you die and restart a lot and won't generally spend a lot of time reading story/lore. In the dark ages of yore, the sorcerer kings crafted the Amulet of Yala to bind the demons of the abyss and end their reign of terror. A golden age followed and the good races flourished. Now dark times have fallen upon the land once more. Demons stir and the forces of darkness once again ravage the land. The Amulet of Yala may be the good folks' last hope. After a long night in the pub, you realize that maybe it is your destiny to recover it and restore tranquility to the land. Only slightly hungover, you set forth into the dungeons beneath your hometown, sure that you can be the one to set things right. Theme. We'll aim for a traditional D&D style dungeon bash, with traps, monsters, the occasional puzzle, and replayability. The game should be different every time. A lighthearted approach is preferred, with humor sprinkled liberally, another staple of the genre. A kitchen sink approach is preferred to strictly focused realism. This is a tutorial project, and it's better to have lots of themes from which to learn than a single cohesive one in this case. Story progression. There is no horizontal progression. You don't keep any benefits from previous runs through the game. So you always start in the same place as a new character and gain benefits for a single run only. You can go both up and down in the dungeon, returning to town to sell items and goods. Progression on levels is preserved until you find the Amulet of Yala, at which point the universe truly is out to get you until you return home. As a starting guide, consider the following progression. It will evolve and become more random as we work on the game. First, the game starts in town. In town, there are only minimal enemies, pickpockets, thugs. You start in the to-be-named pub, tavern, armed only with a meager purse, minimal starting equipment, stein of beer, a dried sausage, a backpack, and a hangover. Town lets you visit various vendors. 2. You spelunk into the caves next to town and fight your way through natural limestone caverns. 3. The limestone caverns give way to a ruined dwarven fortress now occupied by vile beasts and a black dragon. 4. Beneath the dwarven fortress lies a vast mushroom forest. 5. The mushroom forest gives way to a dark elven city. 6. The depths contain a citadel with a portal to the abyss. 7. The abyss is a nasty fight against high-level demonic monsters. Here you find the amulet of Yala. 8. You fight your way back up to town. Travel should be facilitated with an equivalent of town portal scrolls from Diablo. Gameplay. Gameplay should be a very traditional turn-based dungeon crawl, but with an emphasis on making mechanics easy to use. At the base level, this is the murder hobo experience. You start with very little, subsist off of what you find, kill or evade monsters you encounter, and take their stuff. This should be sprinkled with staples of the genre: item identification, interesting magical items, stats and plenty of ways to modify them, and multiple valid ways to play and beat the game. The game should be difficult but not impossible. Nothing that requires quick reflexes is permitted. In a real game design document, we'd be painstakingly describing each element here. For the purposes of the tutorial, we'll add to the list as we write more. Goals. Overall, the ultimate goal is to retrieve the amulet of Yala and return to town. Town portal spells stop working once you have it. Short term, defeat enemies on each level. Navigate each level of the dungeon, avoiding traps and reaching the exit. Obtain lots of cool loot. Earn bragging rights for your score. User skills. Navigating different dungeons. Tactical combat, learning AI behavior and terrain to maximize the chances of survival. Item identification should be more than just identify spell. There should be some hints/system that the user can use to better understand the odds. Stat management, equipped to improve your chances of survival for different threats. Long and short-term resource management. Ideally, we want enough depth to spur build discussions. Game mechanics. We'll go with the tried and tested sort of D&D mechanics used by so many games and licensed under the Open Gaming license, but without being tied to a D&D-like game. We'll expand upon this as we develop the tutorial. Items and power-ups. The game should include a good variety of items. Broadly, items are divided as wearables, armor, clothes, etc., wearable specials like amulets and rings, defense items like shields and similar, melee weapons, ranged weapons, consumables like potions, scrolls, and anything consumed by use, charged items that can only be used X times unless recharged, loot and junk to sell or scrap, and food. Other notes. Eventually, items should have weight, and inventory management becomes a skill. Until then, it can be quite loose/ready. Magical items shouldn't immediately reveal what they do beyond being magical. Items should be drawn from loot tables that at least sort of make sense. Props are a special form of item that doesn't move but can be interacted with. Progression and challenge. As you defeat enemies, you earn experience points and can level up. This improves your general abilities and grants access to better ways to defeat more enemies. The levels should increase in difficulty as you descend. Out-of-level enemies are possible, but very rare to keep it fair. Try to avoid capriciously killing the player with no hope of circumventing it. Once the amulet of Yala has been claimed, difficulty ramps up on all levels as you fight your way back up to town. Certain perks like Town Portal no longer work. There is no progression between runs. It's entirely self-contained. Losing. Oh, we got the Dwarf Fortress motto here. Losing is fun. In fact, a fair portion of the appeal of traditional roguelikes is that you have one life, and it's game over when you succumb to your wounds/traps/being turned into a banana. The game will feature permadeath. Once you've died, your run is over and you start afresh. As a stretch goal, we may introduce some ways to mitigate/soften this. Art style. We'll aim for beautiful ASCII and may introduce tiles. Music and sound. None. It would be nice to have once tiles are done, but fully voicing a modern RPG is far beyond my resources. Technical description. The game will be written in Rust using RLTK/RS for its backend. It will support all the platforms on which Rust can compile and link to OpenGL, including WebAssembly for browser-based play. Marketing and funding. It's a free tutorial, so the budget's approximately $0. If anyone wants to donate to my Patreon, I can promise eternal gratitude, a monster in your honor, and not a lot else. So just for reference, that Patreon is, it's not showing up on the screen right now, but it is patreon.com/blackfuture. And I will open it here just to give them credit where credit is due. Oh, that looks sick. So you might recognize this one here, and you should see bracket. So just want to make sure we do not, pretend that he didn't spend a lot of time working on this or anything, right? Finally, localization. I'm hopeless at languages, so English it is. Other ideas. Anyone who has great ideas should send them to me. And our wrap up. So there we have it, a very skeletal design document with lots of holes in it. It's a good idea to write one of these, especially when making a time-constrained game such as a 7-day roguelike challenge. This chapter will keep improving in quality as more features are implemented. For now, it's intended to serve as a baseline. So my thoughts on this is, if this exact page we just read has been updated, I would have liked to see the different versions, or is this the initial skeleton? So as we go through and say we get to game stats, does game stats say, here are the new updates we're adding to the design document, and that's the only place we see them? Or does this page include all the updates? I would have liked to see both, because, I mean, granted, this is a more full design document if that's the case. And it seems like it. It's got most of the things that I've seen scrolling down. It seems like it's got most of that included. So this is probably the living page as it was described. And it's probably better to see what a real one looks like, but also kind of describing it as skeletal when I feel like there are still holes, but I feel like it's covered a lot of information still. At least based on just looking down at all the different things that are going to happen. Most of this that I can see was covered. All right, so now for the actual coding stuff today. And this is a slightly beefy one, but it's a refactor, so it's not going to be terrible. Depending on how long it takes, I might do the spawn tables, but I think that one's also, it's not bad. We might do it. Depends on how long it takes. Just as a aside, last night I did not do my weekly Genshin Impact stream. I'm planning on doing that today, a few hours after this stream. I got way too little sleep Saturday night going into Sunday, and I just wasn't really feeling up to it. I wasn't feeling that great. So I'm going to be making up for that here in a little bit. So I don't want to run this one too long and not give myself enough of a break to do things. All right, so this one I'm really excited about. I like data-driven design as a concept. It's very useful in games for modding and stuff, and I'm sure we'll read about that here. But I like this approach because it really allows the player to have a lot of freedom. And again, it allows for modding. I like that. I like when players can kind of do what they want. This is just going to make that more accessible. So data-driven design, raw files, only after I get a drink of water. If you've ever played Dwarf Fortress, one of its defining characteristics under the hood is the raw file system. Huge amounts of the game are detailed in the raws, and you can completely mod the game into something else. Other games, such as Tome 4, Tome being Tales of Maj'Eyal, I never heard it called Tome 4. Is that the one on Steam? It's gotta be, right? TE4. Tales of Maj'Eyal. Maybe it is, and I just forgot. Okay. Tales of Maj'Eyal is a great game, though. Other games, such as Tome 4, take this to the extent of defining scripting engine files for everything. You can customize the game to your heart's content. Once implemented, RAWs turn your game into more of an engine, displaying slash managing interactions with content written in the raw files. That isn't to say that the engine is simple. It has to support everything that one specifies in the raw files. This is called data-driven design. Your game is defined by the data describing it more than the actual engine mechanics. It has a few advantages. It makes it very easy to make changes. You don't have to dig through spawner.rs every time you want to change a goblin or make a new variant such as a cowardly goblin. Instead, you edit the raws to include your new monster, add him or it to spawn, loot and faction tables, and the monster is now in your game. Unless, of course, being cowardly requires new support code, in which case you write that too. Data-driven design meshes beautifully with entity component systems. The raws serve as a template from which you build your entities by composing components until it matches your raw description. Data-driven design makes it easy for people to change the game you've created. For a tutorial such as this is pretty essential. I'd much rather you come out of this tutorial able to go forth and make your own game rather than just rehashing this one. A downside of WebAssembly. WebAssembly doesn't make it easy to read files from your computer. That's why we started using the embedding system for assets. Otherwise, you have to make a bunch of hooks to read game data with JavaScript calls to download resources, obtain them as arrays of data, and pass the arrays into the WebAssembly module. There are probably better ways to do it than embedding everything, but until I find a good one that also works in native code, we'll stick to embedding. That gets rid of one advantage of data-driven design. You still have to recompile the game. So we'll make the embedding optional. If we can read a file from disk, we'll do so. In practice, this will mean that when you ship your game, you have to include the executable and the raw files or embed them in the final build. Deciding upon a format for our raw files. In some projects, I've used the scripting language Lua for this sort of thing. Side note from me, Lua is extremely prevalent in the gaming industry. One of the things that you will find in the gaming industry is that a lot of times the engine is there for the raw, heavy lifting and everything. And a lot of the logic that actually happens is offloaded to some kind of a scripting language because it's just easier to do it that way. Lua is a very common one. I first heard about it, I believe, with World of Warcraft or something. Years ago. I don't even know if I was really programming at the time, but I believe that's the first time I heard about it. And I know about a great example is BizHawk. And if we look up BizHawk Lua, BizHawk is an emulator that works with all different kinds of games, all different kinds of consoles and stuff. And if we go to BizHawk Lua functions here, we can actually see that there are all kinds of different things we can do in BizHawk with its Lua API. So if I go to Genesis here, this is what I've worked with in the past. Functions specific to Genesis Hawk. And well, no, those aren't really what I want. I probably want something more like not memory, memory, there it is. Memory or main memory. So you can read bytes, you can read specific memory addresses and stuff. I had a lot of fun doing this with Sonic in the past, and basically looking up memory tables of Sonic and being like, oh, this is where Sonic's velocity is defined, and you can read that in, you can modify it, you can do whatever you want with it. So it's really cool, but that all uses Lua. So it is a very, very, very well-known, popular thing. I believe Factorio uses Lua. Yep, I'm seeing Lua right here. Maybe not here. Let's see. Oh yeah, Lua's here. So Factorio uses Lua. It's all over the place. So if you're interested in scripting in terms of game development and stuff, definitely look into it. So back to the text. In some projects, I've used the scripting language Lua for this sort of thing. Oh wait, one more thing. Rust Mun. I think this one is going to be an interesting one that might be doable. It is still a work in progress, but it is a very Rust-like scripting language. Hot reloading. This is one of the benefits of scripting languages like that, where you don't have to recompile your code. But it has static typing. It uses LLVM. So it has a lot of nice advantages here. It's written in Rust. It's very Rust-like. If we take a look at this here, we can see that a lot of this looks a lot like Rust. Pub fn main. Let is true equal true. Let var equal whatever. I don't know if it has mutability. I think things can just be mutated. It's not exactly Rust, right? But this is one that I've got my eyes on because I think it's going to be potentially very useful in Rust gaming projects Or we could just use Lua, because we could also do Rust, Lua, and Amethyst uses it. High-level Lua bindings to Rust. So we have the foreign function interface module here. But yeah, basically, we could do Lua and Rust as well. All right, so really back to this now. Let's not get distracted. We're half an hour in. In some projects, I've used the scripting language Lua for this sort of thing. It's a great language, and having executable configuration is surprisingly useful. The configuration can include functions and helpers to build itself. That's overkill for this project. We already support JSON in our saving and loading of the game, so we'll use it for RAWs also. Taking a look at spawner.rs in the current game should give us some clues as to what to put into these files. Thanks to our use of components, there's already a lot of shared functionality we can build upon. For example, the definition for a health potion looks like this. We see our function there, health potion, and we just add components, right? With position, with renderable, with name, with item, consumable, and so on. In JSON, we might go for a representation like this. Just an example, name, healing potion, which is, that corresponds to that component, obviously. Renderable, it's almost a one-to-one of what we see here, although I'm not seeing the render order. So that one's interesting. Again, this is just an example. And then consumable. Effects provides healing, and then 8. Which kind of matches this. Okay. So now we're going to actually make a raw file. Your package should be laid out like this. Root folder, source, and then we're going to have raws next to source. In this directory, we'll create a new file, spawns.json. So let's take care of that. We'll open this bad boy up, and new folder. And spawns.json. We'll temporarily put all of our definitions into one file. This will change later, but we want to get support for our data-driven ambitions bootstrapped. In this file, we're going to put definitions for some of the entities we currently support in spawner.rs. We'll start with just a couple. So JSON is interesting. I prefer something like YAML if I can, but it is what it is. So let me just copy this instead. I thought there was an extra. Yeah, there is an extra one. That's why I hesitated, because I was like, wait a minute, there's an extra one on the text. I have my auto formatter and everything, so it looks nice, and we got it in here. We're good to go. So very simple. It feels a lot like the way we make our structs in Rust. So it's not horrible, but there are some oddities, like we put these in strings and all that. There is JSON 5, which has some improvements. I do prefer that over regular JSON. For example, in regular JSON, if I do this, we see there's a problem with the trailing comma. JSON 5 does not have that problem, but it's nowhere near as ubiquitous. However, there is a good Rust crate for it. YAML is very similar, except it gets rid of a lot of the unnecessary brackets, curly braces. It gets rid of like a lot of the quotes and stuff, I believe. It's just a simpler version, basically. That's why I kind of prefer it if I'm doing something like this, but whatever. There's our basic thing. It's basically what we just saw with, we have a health potion, the glyph. We do have the render order now. Consumable effects provides healing. Consumable effects, range, and damage for this magic missile scroll. Very simple stuff, right? Shouldn't have to explain it. If you're familiar with the JSON format, it's basically a JavaScript dump of data. We wrap, it's JavaScript object notation, I think. We wrap the file in the curly braces to denote the object we're loading. It's going to be our raws object eventually. Then we have an array called items, which will hold our items. Each item has a name. This maps directly to the name component. Each item may have a renderable structure listing glyph, foreground, and background colors, and the renderable. These items are consumable, and we list their effects in a key value map, basically a hash map like we've used before, a dictionary in some other languages. We'll be adding a lot more to the spawns list eventually, but let's start by making these work. So embedding the raw files. In your project source directory, make a new directory called source raws. Oh, in source, we need a raws directory. Okay. We can reasonably expect this module to become quite large, so we'll support breaking it into smaller pieces from the beginning. To comply with Rust requirements for building modules, make a new file called mod.rs in the new folder. And I'll do that, and I'm going to sneeze, so I'll be silent for a moment. Alrighty. We're going to want to add that to main. Let's get to the top of main here. Oh, I typed not mod. There we go. Now it's happy. Okay. So now here in mod.rs for raws, we're going to need a couple things here. I don't know what's going on with my nose today, all these sneezes. It's terrible today. Yeah, I still have another one building up. I have this whole time. In fact, let me go blow my nose, see if that helps. So far it hasn't helped. But also, I'm trying to figure out if my directories are right. I think they are, because we're in raws. We want to go up to source, and then we want to go up again to get to raws, the other raws. So I think we're good. Okay. So we do this embedded resource, link resource, and I think, would this complain? Is this macro going to complain if it's not found? No, it's not. Okay, whatever. I think we're good. Dude, how am I supposed to talk? I can't not... it's bugging me so much right now. All right, so basically though, RLTK embedded resource, we're calling it raw file, and it's just spawns.json, and we're linking the resource as well. There is one other thing we can kind of do, by the way. Let me show you. So we could include bytes or string, or just whatever this one is. I haven't used this one, but let's say we do include string. So now we actually pull that file in as a string, and if I do this, it should get mad because it can't find it, right? So it can't read it. It actually checks that now for us. But what that does, that just reads in the file as a string, but it does it at compile time. So it actually like includes it encoded as a string. It's located relative to the current file. Provided path is interpreted in a platform specific way at compile time. So it's not like reading this in later. This actually gets baked in, which is very useful. Okay, one more moment. Okay, I think I'm better. Maybe. All right. Sorry about that. I don't know what was going on. So we made that very simple thing, embed and link the resource. At the top of main, add it to the list of modules. We just did that. In our initialization, we add a call to load raws after the component initialization and before we start adding to world. We come down here, there's door, and then we'll do, oh no, we don't. Yeah. Go down here. There it is. And that's all we're doing now. We just load raws. But now we have to parse them. The spawn's JSON file will now be embedded into the executable, courtesy of our LTK's embedding system. So we're going to parse the raw files. This is the hard part. We need a way to read the JSON file we've created and turn it into a format we can use within Rust. Going back to mod.rs, we expand the function to load our embedded data as a string. Okay, so we link the resource. Then we're going to retrieve the raw data as an array of U8s. In C, C++, you would just do unsigned char. So that's why it says, that's why that's there in the comments. And let's see how this is going to work. All right, let's break this down. Is that the full? Yeah, that's the full comment. Good. Or full thing there. So we have raw data. Is this RLTK embedding embed? Oh. Something's different. It's still valid. Okay. Maybe there's a typo in the tutorial or the API changed. It could be both. So this thing is getting us this mutex guard, which I think we've seen before, of this like dictionary of all the resources. And then we're telling it we want this resource, spawns.json. And then it gets us that data as this U8, as this slice of U8s. So we say raw string is to take that raw data and just save it as a string. So that's fine with me. What's going on, Rose? I got that. This will panic crash if it isn't able to find the resource or if it's unable to parse it as a regular string. Rust likes UTF Unicode encoding, so we'll go with it. Lets us include extended glyphs, which we can parse via RLTK's 2CP437 function, so it works out nicely. Now we need to actually parse the JSON into something usable, just like our save load RS system. We can do this with Serday. For now, we'll just dump the results into the console so we can see it did something. Let's head over there and do it. I'm okay, I'm better than yesterday. My nose is bothering me. So we're just gonna do it here. So let decoder raws equals Serday JSON from string raw, give it the raw string dot expect unable to parse JSON. I'm gonna put another line between this. Alrighty. What can you not find? Oh, raws, of course. Have we not done this before? The tutorial is calling it out. It's to see the cryptic. You got your curly braces with the colon question mark. That's a way to print debug information about a structure. This will fail to compile because we haven't actually implemented raws, the type it's looking for. For clarity, we'll put the classes. They're not classes, don't do that. We'll put the classes that actually handle the data in their own file. That's in the text. I'm just reading the text. So we're going to have item structs. Yeah, they're structs. They're not classes, dude. Bothers me more than it should. All right, so in item structs, we're going to need a couple simple things. We're going to need Serday deserialize. Not that. We're going to need the hash map. And now we're going to need a couple things here. Pub struct raws. And it's going to be a vec of item. An items field, which is just a vec of item. And guess what? We don't have item yet. And we don't have renderable or consumable. So we got all our basic data types, but we can't actually print them yet. And we'll show that in a moment. I'm deviating a little bit. Let's just do use item structs everything. And now it says it doesn't implement debug. So I wanted to do this my way a little bit here. So we're going to go, what are we trying to print that doesn't implement debug? Well, it's raws, right? Item structs raws doesn't implement debug. So we're going to derive debug for it. And now it's actually still going to be mad because item doesn't do it either. So then we have to go all the way down to item. But item also has renderable and consumable. And so we have to do it for both of those as well. And that's the main thing I wanted to point to, is just how that has to go all the way down the chain. We're also going to need a couple other things, though. We're going to want deserialize as well. We brought it in for a reason, so we're going to want deserialize. And then it's like, yo, that doesn't do it. So the same thing. It has to go all the way down the chain to make sure we can deserialize everything. And now we've satisfied all those constraints there. So basically, we have a raws struct that has a vector of items. Each item has a name, which is guaranteed, and it may have a renderable component, and it may have a consumable component. Renderables have the glyph, the foreground, the background, and the render order. The consumables have a hash map of effects, mapping a string to a string. And that's it. So let's read through this. Also, don't worry about it. You'll pick up some code just watching. At the top of the file, make sure to use Serity deserialize and hash map. Yep, we did it. To include the types we need. Also notice we've included debug in the derived types list. This allows Rust to print a debug copy of the struct so we can see what the code did. Notice also that a lot of things are an option. This way the parsing works if an item doesn't have that entry. It'll make reading them a little more complicated later on, but we can live with that. If you cargo run the project now, ignore the game window, watch the console. You'll see the following. Yeah, so let's do it. That's one of those things, like the line about it'll make it a little more complicated later. While true, that's good. We want that complexity because that's preventing us from having errors. Now, if we just close the game out, we see right here, raws, items, all that good stuff. It's a little bit messy. I don't know if they do it in the tutorial, but I'm going to add in the middle of the colon and the question mark there where we're printing out the raw string. I'm going to add that pound sign. And if we run it again, that does a pretty print on it. So it takes up a lot more room in the console, but it's going to be more readable. I'll just show it real quick. Yeah, look at that. That's my console now, but it looks just like the file. Just to show that it's really what it should be. Except now, we also see these are Rust types, by the way, right? These are Rust data types because we see some. I don't know, do we have any nuns in here? They're both consumable, they're both renderable. Okay, I got partially cut off there because I'm screwing with the console too much. But yeah, that we see the sum there, so it's like it's the optional types and everything, so we're taking advantage of some of the Rust there. Alrighty. We don't need that. I was actually going to comment on that. I was going to ask why we put the references, and I was going to say for the, none of this is RLTK, but what you should generally do is take in a string slice. So if you're writing a function, you should usually want to take in a string slice. So like that. And then when you're calling it, you can do two things. So you could say let test string equal this is a test of the emergency broadcast system .toString. So now we have a capital S string type, and we can say test ampersand test string, and that works. And we can also say test with that, and that works as well. So by doing the string slice, the ampersand str as our parameter, we can actually pass in both kinds just by putting the reference before the capital S string. Okay. So we cargo ran, we got what we wanted. It's super ugly and horribly formatted, but you can see that it contains the data we entered. So now, storing and indexing our raw item data. Having this largely text data is great, but it doesn't really help us until it can directly relate to spawning entities. We're also discarding the data as soon as we've loaded it. So we want to create a structure to hold all of our raw data and provide some useful services such as spawning an object entirely from the data in the raws. We'll make a new file, raws/rawmaster.rs. And let's bring in the boilerplate use declarations there. So we're going to bring in components. We're going to bring in the prelude of specs. We're going to bring in the super raws. And we're going to bring in the hash map. And we should add this as well. So now we'll get our proper highlighting and stuff. Okay, we're good to go. Now, we have this raw master struct, which is just something raws. With some item index. Oh, string usize, my bad. Which maps a string to a usize. And here we have an empty function to basically build one, a constructor, if you will, with new, a raws with just an empty vector and an item index that's empty, very simple, nothing special about that. We'll also have pub fn load, which is basically going to be the same thing, but it's going to take in a raws. So it's going to take in a raws. Oh, actually, this is loading. It's a little bit different because it's taking in a mutable reference to self, but it just sets the raws to whatever's passed in, and the item index is a new hash map, and then we iterate over the items in the raws that got passed in. And we index them. We basically take the name of the thing and get the index. So remember, that's the item index map here. And I'm guessing that's so we don't have to iterate through everything. We can just check against the hash map to maybe do it a little bit faster in certain cases. So that's very straightforward, well within what we've learned of Rust so far. We make a structure called rawmaster. It gets a private copy of the raws data and a hash map, storing item names and their index inside raws.items. The empty constructor does just that. It makes a completely empty version of the rawmaster structure. Load takes the deserialized raws structure, stores it, and indexes the items by name and location in the items array. Accessing raw data from anywhere. It's one of those times that it would be nice if Rust didn't make global variables difficult to use. We want exactly one copy of the raw master data, and we'd like to be able to read it from anywhere. There's something, I think they would call that a singleton. That's a bit of a difficult pattern in Rust. But, well, you want it everywhere. I don't know if that would still be a singleton, but whatever. You can accomplish that with a bunch of unsafe code, but we'll be good Rustaceans and use a popular method, lazy static. This functionality isn't part of the language itself, so we need to add a crate to cargo.toml. For the record, I believe lazy static is basically maintained by the Rust team. Because I was always kind of weird about it. myself. I was like, ooh, I feel like I'm doing something weird. Like I feel like I'm cheating or something. I don't know. But what I think I read at one point was that it's actually basically being maintained by team. It's about as official as you can get without being part of the language. So you shouldn't feel bad about using it. So we'll do a bit of a dance to make the global safely available from everywhere. So at the end of main's import section, we're going to do this. They're doing it in a way that we don't have to do anymore. Extern crate is no longer needed. So we're going to try and get away from that. It's similar to, yeah, so they do. They do this here. But I feel like we can... I feel like we can get away without doing any of that. That's fine. We'll put it for now. We'll see what happens. In mod.rs, so back in here, mod rawmaster, use rawmaster star. We're going to bring in a mutex. And then we're going to do lazy static. So here's a fun thing. I'm going to do something a little bit differently. Oh, is that actually... Macros that expand to items must be delimited with braces or followed by a semicolon. Ah, okay. I didn't realize that. Never mind, so you can't do the thing. It's my understanding, though, that with macros, you can do... Like, if we go down here... Print line... Yeah, see that we could do that with the braces. We can also do square brackets. We can also do parentheses. Macros are a little weird in that, but it depends on how they work. So in that case, we had to do braces. Okay. That's what I was going to show, and it didn't work in the one case that I was trying it here with lazy static. But anyway, lazy static, let's read about the macro if I can. Using this macro, it's possible to have statics that require code to be executed at runtime in order to be initialized. This includes anything requiring heap allocations like vectors or hash maps, as well as anything that requires function calls to be computed. For a given static ref name, type equal expression, the macro generates a unique type that implements deref type and stores it in a static with the name. Attributes end up attaching to this type. On the first deref, expression gets evaluated and stored internally such that all further derefs can return a reference to the same object. Note that this can lead to deadlocks if you have multiple lazy statics that depend on each other in their initialization. Apart from the lazy initialization, the resulting static ref variables have generally the same properties as regular static variables. Any type in them needs to fulfill the sync trait. If the type has a destructor, then it will not run when the process exits. All right, so we have a mutex with a raw master inside of it. And right now we just made a new mutex with the raw master, very simple. So the mutex is going to be important. That's mutual exclusion, and that's one of the things you can use to synchronize shared data. So primitive useful for protecting shared data. So we can basically lock the data down, and while I'm over here using it, it's locked. Nobody else can unlock it, or nobody else can lock it themselves until I unlock it. So let's read the tutorial text here now. The lazy static macro does a bunch of hard work for us to make this safe. The interesting part is that we still have to use a mutex. Mutexes are a construct that ensure that no more than one thread at a time can write to a structure. You can access a mutex by calling lock. It's now yours until the lock goes out of scope. So in our load raws function, we need to populate it. So we will retrieve the raw data as an array of U8, which we're doing. We get the raw string, we get the decoder, and now we lock down raws and we load the decoder. So we've already put that load function there. So let's take a look at that load function one more time. It takes raws, but we've already deserialized into raws. So decoder is actually our raws, right? I was thinking it was a string for a second. No, decoder is our raws. And we can just pass that into the load function we already made. So raws.lock.unwrap.load decoder. And that's it. So now we've got them in this lazy static that other things can look at, other people can see. We'll notice that RLTK is embedding systems quietly using a lazy static itself. That's what the lock and unwrap code's for. It manages a mutex. So for our raws global, we lock it, retrieving a scoped lock, unwrap that lock to allow us to access the contents, and call the load function we wrote earlier. Quite a mouthful, but now we can safely share the raws data without having to worry about threading problems. Once loaded, we'll probably never write to it again, and mutex locks for reading are pretty much instantaneous when you don't have lots of threads running. Spawning items from the... Actually, I would mention, in a lot of cases, benchmarking is very important because people can be too concerned about performance. And sometimes you have to think about profiling and where your performance hits and bottlenecks are going to be. Are we ever going to be using raws and performing, accesses to raws outside of map generation? I don't know yet. We'll see what happens later. How data driven are we going to go? Right now, if we're just spawning things, that's only during map generation with our current setup, right? So who cares about a little bit of a performance hit during map generation that the player's not going to notice? If we need to call this every frame as a system runs, that might be more of a concern, but probably not still in this case. And this is where it gets to another point that I wanted to make, is that profiling, understanding how things are going to be used, and understanding the impact that they actually have is really important. I saw a write-up recently where they compared how expensive Rust's bound checks are. And let's see if I can find it. It was pretty recent. Oh, the 14th of December, 2022. How much does Rust bound checking actually cost? We'll just skim it. It prevents out-of-bounds memory accesses and buffer overflows via runtime's bound checks. What's the cost of them for a real-world production application? Recently, a pair of critical vulnerabilities were reported in the OpenSSL project, surprising absolutely nobody. The root cause of both vulnerabilities turned out to be a buffer overrun, which could be triggered by an attacker with a malicious payload to cause a crash and denial of service. Predictably, many Rust advocates, of which I am one, pointed out that this is exactly the kind of vulnerability that can be statically prevented by Rust, and is a clear example of where rewrite it in Rust can have real benefits. Setting aside the feasibility or advisability of a ground-up rewrite of a project as large, complex, and long-lived as OpenSSL, it's worth talking about exactly how Rust is able to prevent these kinds of buffer overflow vulnerabilities. Specifically, since Rust isn't a fully dependently typed language where we can prove the lengths of our buffers at compile time, it resorts to runtime bounds checks to ensure that indexing always remains safe. In practice, this means that every time you index into a slice, the Rust compiler will emit a sequence of instructions that checks if your index is within the bounds of that slice, and panics if it isn't. There are unsafe ways of opting out of bounds checking when indexing, like get unchecked and get unchecked mute. And they're definitely used at least some of the time, but not all of the time. And not even when it could be statically determined that the index is in bounds. This is a good thing for safety because these are exactly the kinds of edge case properties that are easy to accidentally break in a way that automated tests don't cover. For C programmers, this can sound like a downside of Rust. There aren't many places in real-world code where you in fact statically know that your index is in bounds, or places where you do multiple indexing operations into the same slice that a single bounds check on the maximum index could cover all indexing operations. Overall, it's probably not a zero-cost abstraction, at least under Bjarne Strustrop's original definition. What you do use, you couldn't hand code any better. What is the actual cost of all this extra bounds checking, though? There's a little bit of prior art here. For example, this repository, which contains benchmarks, which index into slices and tight loops using both the safe bounds checked version and the unsafe non-bounds checked version. The conclusion there was that at least in this scenario, bounds checking is usually only a cost when its presence prevents optimizations such as auto-vectorization, which can be a huge optimization in practice. But otherwise, it's basically a wash. On the other hand, I wasn't able to find an extensive analysis of the code of pervasive bounds checking on a real large production Rust code base with high performance sensitivity. I happened to work on one of those, so I figured it might be interesting to take a look at the cost of bounds checks in the hot path. We have this ready set here. That's beefy, yeah. SQL caching engine designed to help developers enhance the performance and scalability of their existing database backend applications. So we just take a look here at some of the results. Let's just scroll down. How much do bound checks cost? Even with only... let's see. The baseline performance metric we're trying to improve over is a median 28.583 milliseconds, 277.45 thousand queries per second. And 18 milliseconds, so okay. Yeah, I think there is a table. I want to see that. Yeah, so basically, I'm not going to go over every single thing here because it's a lot to break down. But the big takeaway here is at the end of the day, it seems like, at least for this kind of large-scale complex application, the cost of pervasive runtime bounds checking is negligible. It's tough to say precisely why this is, but my intuition is the CPU branch prediction is simply good enough in practice that the cost of the extra couple of instructions and a branch effectively ends up being zero. And compilers like LLVM are good enough at local optimizations to optimize most bound checks away entirely. Not to mention, it's likely that quite a few, if not the majority of the bounds checks we remove, are actually necessary, and that they're validating some kind of user input or other edge conditions where we want to panic on an out-of-bounds access. All right, let me get a drink of water. So notice, back to this now. The reason I mentioned that and went on that tangent is because the idea of being concerned about performance of every little thing is not always realistic, is not always something that you should care about. And that example really proved it, right? Because at least in one case, we have benchmarks, we have some raw tests and examples there that show, okay, we're doing all this bounds checking, but it's actually not really causing any problem. And that's the thing with mutex. In a lot of cases, as it's mentioned here, it's practically zero. You don't have to worry about it. And again, it comes down to where the code is being used. Is it in a hot loop? What's going on, right? Is it something that runs during map generation which right now this is where this is going to be used during map generation. Well, the user's not going to care. It's not going to affect the gameplay. It's only going to happen during map generation, and they'll never notice, right? So that's just kind of a bit of a real world example with like some data to back it up about what we're talking about here. So moving on. Spawning items from the raws. So in raw master, we're going to make a new function called spawn named item. That's a big old beefy boy. So let's take a look at it. And this is just a... Yeah, this is not in the impl. So we're just going to put it down here. What is this? Spawn type. Let's get that formatted. And let's get started here. So we're taking in a raw master reference, an entity builder, a string, which we're calling key, and POS, which I would assume is position. We're calling it, it's a spawn type though. So it might be like an enum or something that tells us how to position it. We'll see. Yeah, this will be fine. So if raws.itemindex contains key, the key that we passed in, we're gonna make like an item template here. I think I might refactor this a tiny bit, but we'll get the function out first. Why are you mad? Did I do something wrong? Okay, let me just go to the end here and put a none. That's going to help as well. Yeah, see, I didn't do anything wrong. It's just like, hey, you're not returning the right stuff. What are you doing, man? Sometimes it gets a little prematurely angry. Okay, so we'll do none there as our fallback. And then that's actually going to be the final thing we leave there anyway. So we're going to do early returns in the case that that we do have something. So we get this entity builder and spawn in the specified location. So we have this spawn type, which is potentially an enum. That could be like a static function, but it's probably an enum called @position that has an X and a Y because we're matching on it. No, that's not a function. Yeah, we're matching. Excuse me. I'm stupid. Don't listen to me. I forgot we're in a match. So yeah, that is an enum then. Unless we're pulling in a struct called @position from like a scope called spawn type. But I doubt that's the case. So where am I at again? There we go. Next, renderable. If let some renderable we're just ripping out the renderable thing that we got if we did. And this is a case where let else doesn't make sense because we only want to do this if there is a renderable. and we just want to keep moving on otherwise. So if let is actually what I would want here. Oh, wait, we're not. Yep, we're building out a struct. All right, I'm going to be a little lazy here. I don't want to type all these RGBs and stuff. But let's look at it though, just so we don't want to be that lazy. So we're actually building out our component, our renderable component, and we're adding it to the entity builder. So this is like what we do in the spawner, right? Where we saw it at the beginning where it's like, make me a thing with this component, with that component, with this. These are the dot widths, right? These are the dot widths that we are basically seeing over there. But instead of chaining them, we are adding them only when necessary because we're doing it dynamically now, right? eb equal eb.width name. So that one has to be there, so we don't need to do anything fancy. We're doing with items, so we've assumed this is only going to be taking items, I guess. Item index and all that, sure. And then if let sum consumable equal end item template. All right, so if there's consumable, we're going to add a consumable component. And then for each of the effects that we have here, we're going to have to try to like add these effects. Heal amount effect dot one dot parse I32. I hate when these lines go on so long. I have to go over to the browser and scroll it left and right to read the full lines. And now when I save, you see we get a format here. That's way better. But I can't just do that from the browser. So if it has a ranged effect, then and then if it has a damage effect, it's basically the same thing, but I'm not going to type it this time. So we just make an inflicts damage component and we parse the number and add it to the damage field. And then in the last case, if it's none of that, consumable effect blank is not implemented. So we don't actually crash, which is good. And then here, if we've done all that, Boom. We returned some eb.build. So the thing I was thinking about that I would kind of do maybe as a refactor, we don't even really need the return there. We could just put an else on this and do none. But I was thinking we could also do, we could just get the key. We could do if let raws.item index dot, wait, what? Oh, I think it's, is it mad because of the spawn type? Oh, there we are. All right, now we can do get. The thing is, we're not, no, we're not actually getting that. Yeah, it's kind of okay then. I'll leave it. We're gonna leave spawn type for the moment. But again, just to break down the logic, because it is, to me, it's pretty easy to follow. If the key is in there, and the key is just a string here, but then we can use that key to get the raws items. And then we take this entity builder, and we just keep adding the appropriate things to the entity. What do I mean by appropriate? If there is this position thing, then we destructure it basically to, well, actually no, yeah, that's not option. Position is there. So not if there is one, but we match on the position to destructure the X and Y values out of the at position. And then we add a position component to the entity builder, right? To the entity. If there's a renderable, then we basically rip all the stuff that we need out of it and build a renderable component. We add the name component. We add the item component. And then if it's consumable, we set up all the effects by matching against the effect name and parsing the data associated with it. It's pretty straightforward, I think. So next, it's a pretty long function, but it's actually very straightforward and uses patterns we've encountered plenty of times before. It does the following. It looks to see if the key we've passed exists in the item index. If it doesn't, it returns none. It didn't do anything. If the key does exist, then it adds a name component to the entity with the name from the raw file. If renderable exists in the item definition, it creates a component of type renderable. If consumable exists in the item definition, it makes a new consumable. It iterates through all of the keys/values inside the effect dictionary. So the one refactor I was thinking about at the end, though, is I don't think if let would work too well on this one, but we have this if, get rid of the semicolon, get rid of the return, put this none and an else. And then the if returns what it needs to, and the else returns the none. To me, seeing the return statement basically right next to an implicit return just feels like it's weird, it's inconsistent. So it looks to see if the key we passed exists in the item index. If it doesn't, it returns none, didn't do anything. If it does exist, it adds a name component with the name from the raw file. If renderable exists, it creates a new component of the renderable type. If consumable exists in the item definition, it makes a new consumable. It iterates through all of the keys/values inside that effect dictionary. Now we can open spawner, but where is spawn at? We're probably almost done if spawn type. Um, do we have that somewhere? I don't recognize it. I just went through everything. Is it not spawn at? Oh, spawn type. Dude, that's the only one that shows up. Let me look up at position. Okay. Is it defined in the next lesson? What's going on with that? Where do you want it? Like, I can put that in here. I could do that. It's gonna make it happy. But I don't know where all we're using it and how we're wanting to use it. So it's a bit of a pain. I don't see it being defined anywhere in the file, so we're just gonna go with my quick and dirty, just put that enum here and roll with it, okay? The reason I say we may almost be done. We're only like halfway through, not even that maybe, but there's going to be a lot of copy pasting going forward because it's going to be a lot of it's stuff we've done. It's just going to be a bunch of JSON and stuff, I think. So we're going to go to spawner.rs and modify spawn entity. So where is it at? Spawn entity. Whoops. Right here. So we do the map, width, XY, standard mem drop map. Now right here, let item result equals spawn named item and raws dot lock dot unwrap ECS dot create entity and spawn, and now I have to scroll over because it just keeps going. Yeah, it's way too much for one line. All right, if item result is sum, return. And there's a couple differences here. Door, bear trap, magic, rations, tower, shield, longsword, shield, dagger. Magic missile scroll is gone. Confusion, fireball, health potion. All right, bring in all the raws. We still don't have spawn type. So let's go back to this mod, and we're gonna say pubmod raw master. Still not finding that though. How did we do it on the map thing? No, it's not in the map, it's in main. Let's do pubmod, right? Yeah. I mean, I guess I can just bring this stuff in. Raw master. Whoops. Do that. And I don't need that anymore. So there's one thing that, yeah, we can get rid of this. There's one thing I'm looking at that I think I would change. Although I'm a little bit intrigued. I'm not reading this incorrectly. No, I get it. Because we're already doing the spawn. So if it's in spawn named item, we're already doing the spawn, so we don't need to do anything here. But if we're not using item result here, I wonder why we don't do something a little bit different, which would be like this. If item result dot is sum. Well, not item result. Sorry. That's what you get when you just start refactoring blindly. You do something goofy like that. I wonder why we don't just do this. Whatever. Tutorial is God. So we deleted the items we added into spawns.json. We can also delete the associated functions, which is probably what's yelling at me here. Health potion and magic missile are gone. Spawner.rs is going to be really small when we're done. So the magic here is that it calls spawn named item, which we see here, using a rather ugly and raws.lock.unwrap. That's an opinion. I don't think it's that bad. I think the unwrap is bad. To obtain safe access to our raws global variable, if it matched a key, it'll return some entity. Otherwise, we get none. So we check if item result is sum, and return if we succeeded in spawning something from the data. Otherwise, we use the new code. You'll also want to add a raws :*. If we cargo run, the game should run as before, including health potions and magic missile scrolls. Maybe I'll run around long enough to get a health potion. They're pretty common. Wave function collapse is performing a bit better on the new, like, refresh of the whole project. But I do still have some odd ones from time to time. Yeah, I just need a potion. Come on, guys. There we are. We got potions. We're good. All right. So now we're going to add the rest of the consumables. So spawns.json. As I said, it's going to be a lot of copy pasting kind of stuff here, which is good for me. I'm not going to type out every single one of these that's already in our code, right? That's pointless. So now we have health, magic missile, fireball, confusion, magic mapping, and rations. We'll put their effects into Rawmaster's spawn named item function. So we're just going to go right back over here. And this is the same thing. I'm not going to type all these out, just being honest. You'd have to if you're really doing the refactor, but it's all the same thing. In fact, you would be able to copy paste most of this, but you have to change the name of the component and the name of the field of the component. In the case of magic mapping, there is no other component, or there is no there is no like thing that you parse, rather. I'm saying component, but yeah, that was right. The component's like inflicts damage or area of effect, and then the field is radius or damage or whatever. So that, I mean, it's like the same thing for all of them, right? I'm not going to copy, or not going to type that. So we can delete all those other ones from spawner.rs. So what was it? Fireball, magic mapping, and confusion. I think rations was in there. Wait a minute, did we put... Yeah, food's in here, okay. I'm stuck on that for a reason. I'll explain momentarily. So the tutorial text says you can now delete fireball, magic mapping, and confusion. It doesn't mention rations, but food is here, and rations are here, and they provide food and all that, so I think we're good. You can now delete the fireball, magic mapping, and all that, run the game. All right, take it easy, Rose. I'll be back in a few hours, making up for the Genshin stream that I didn't do yesterday, here in about 4 hours. I will catch you later. Have a good one. So run the game, blah, blah, blah. We got all that. Cool. Hopefully it's starting to illustrate the power of linking a data file to your component creation. Now add the remaining items. Make a few more. These are going to be different because they require things that aren't covered by what we've already done. Like the shield like the shield thing there, weapon. Those are going to have to expand our item structs. Oh, actually, before we do that, let's run the game. Let's look to find some rations or something. You know, I've probably mentioned it before, but every time I think of rations, I know they're obviously, there they are, perfect. I know they're obviously a real thing, but growing up playing Metal Gear Solid back in the day, and currently replaying the entire Metal Gear Solid series. Oh, this room is huge. That's cool. I just wish there was something in here. Maybe a trap that we didn't identify. Replaying Metal Gear Solid, the whole series right now, is definitely, every time I hear the word rations, that's all I can think about. Alrighty. So now, shield and weapon are the new fields that we added. So we need to go back to our item structs and add 2 things for that. So we're going to do the basic ones here. Weapon and shield, and let's take a look at them. Weapon has a range and a power bonus. Shield has a defense bonus. That's very much like what we've already done with our components in the past. And then we're going to need to account for those here. Whoops, I cannot type. All right, we get our weapon and shield going, and we're happy. Cool. So now spawn named items over here doesn't know what those are. So that's where I was saying before, we're going to have a little bit of extra work to do here. So we could kind of put that wherever. You could put it after consumable, before consumable. It doesn't really matter. I'm going to put it up here. If let some weapon equal and item template dot weapon. We're going to give it an equipable component, and the slot is melee. And we'll do that power bonus thing. And that got parsed for free from our JSON. Well, not for free literally, but kind of for free from our JSON because of item structs, right? So maybe I'm beating a dead horse here, but let's be clear. This item struct literally here is a one-to-one representation of our JSON. So every item in our JSON has to match this struct here. It has to have a name. However, these are special. It can optionally have renderable. It can optionally have consumable. It can optionally have weapon. It can optionally have shield. But if it has a renderable, it has to have all of these. If it has a consumable, it has to have this effects map. If it has a weapon, it has to have these. So if we go to spawns here, we look at this one here, rations, and we see it has renderable, so it's got those four things. It has consumable, it has the effects map, right? So that's the critical thing. If it doesn't have those, the option automatically gets resolved as none, and that's what I mean by we get all that like built in for free. Why is that mad? Oh, because I copied something I didn't need. Okay, hang on. What's wrong? Oh, there was just an extra one. Well, there needed to be an extra one. Okay, because I never added these. I got sidetracked when I was like, let's run the game first. All right, so back to here, and shield is basically the same as weapon. So I'm going to be lazy and just bring that one in for us, like so. If there is a shield component, then add equipable slot shield, add defense bonus with the shield.defense bonus. Very, very simple. We can now delete those from spawner.rs, and we're good to go. So what all did we add? We added longsword and shield, power shield and dagger. Look at that. Look how easy that is. It's great. Next, we'll go ahead and run the game actually, and then we're gonna do the monsters. And this is why I said that it's gonna move a lot quicker all of a sudden, because there's a lot of this, a lot of very simple stuff here. But if you're paying attention, what should you be thinking about right now? We save monsters, we don't have the trap, we don't have the door yet. You should be thinking about what's going to be different. I guess we have the longest one to wait through here, but I'll talk during that. What's going to be different? When we just did weapons, we had new components to worry about, right? That's the kind of thing that we should be thinking about as to what's going to differentiate monsters and stuff. So we haven't seen a view shed yet. We haven't seen a monster component yet, a blocks tile component, a combat stats component. I guess we're going to have to worry about... No, we're not doing the serializer? Did we take care of that somewhere else? Is that an oversight? It could very well be. That serialize me thing, that's used for our saving and loading. So put a pin in that. That's a good point to notice there. But yeah, all I wanted to bring attention to was the fact that we have all of these components that we haven't used yet. That's going to be the unique thing about monsters and any of these other ones, right? In the background here, I'm going to delete Fireball Scroll. I'm going to delete Dagger and Confusion Scroll. I'm going to delete Magic Mapping Scroll and Rations and Tower Shield and Longsword and Shield. And now our file is much, much shorter. And after what we added, well, there's Fireball Scrolls right there. That's a shield. Oh, that's a Magic Missile Scroll. Get me out of here. There's a weapon. We got a dagger, so we know the weapons are at least working now. Let's head back over and check things out. So we're gonna do some monsters now. We'll add a new array to spawns.json to handle monsters. We're calling it mobs. This is slang from minigames for movable object. I never knew what that came from. That's cool. So we'll just, we'll go down to the bottom here. Right after items closes. And we'll do that. Now we have mobs. Now, if we try to run that, we're going to have a problem. And there is some tutorial commentary here as well. You'll notice that we're fixing a minor issue from before. Orcs and goblins are no longer identical in stats. Otherwise, it should make sense. The stats we set in spawner.rs are instead set in the JSON file. We'll need to create a new file, mobstructs.rs. Okay, yeah, duh, we're not going to put it in items. I was just kind of thinking about that, but yeah, I forgot the name of the file was even items. Item structs. I'm just rolling with it. So in raws, we're going to say mobstructs.rs. And this is one of those that's just a little bit too boilerplatey now, so I think we've seen how to do it. But let's break down, and in fact, I can and will do this side by side here. Although it's going to be a very tight squeeze, but I think we can see everything. So we have a mob, and a mob has a name is required, so orc is our name. Renderable is optional, but we do have renderable on both. Blocks tile is our boolean. Pub stats is our mob stats. Take a look at that in a moment. We also have vision range. And they have the same ranges, but the orc has twice as much health and one more power than the goblin. So stats up here on our Rust just says pub stats, mob stats. So then we have mob stats here. And that's perfectly fine, right? That, like, again, we're kind of just defining what that JSON is going to look like. So then we need max health, power, and defense. You can do some stuff. There are some tools online which will actually generate structs from JSON, and you can make them safe structs as well on making fields optional and stuff. There's some really cool tools for that. You have to be willing to give over some JSON. I mean, I don't know data collection policies or whatever on the websites, so you have to trust it or say this is data I don't care about, or anonymize it and make it dummy data that's the same basic structure as yours but doesn't reveal any information if you're concerned about that. Just handing data to a website, you know, just be careful. That's all. So we have mob structs. We're not using it anywhere yet. We're going to need it in raw masters. Actually, we're going to need it in, yeah, raw master, right? Yeah. So we have the item stuff here. Oh, no, wait. We do need raws. We're going to move this. That's why it was confusing me. We're going to move raws out of here. And we're going to put it probably in the mod, since it's shared now. So we'll put this here. We're going to need Saturday to come in here. And then we're also going to need pub. Ooh. We need that. So now you should know the other thing we need to do. Mod mob structs. I think we're good there. So we have a mob list now, just the same as the item one. And we're going to need to go to raw master now and do some stuff there. So we're going to need use super raws. We'll have an empty vector once again. I think we might do a mod. Yeah, we're going to do a mob index as well. Actually, we'll just copy that line and do mob index. So in the case of our empty, very, very simple. In the case of that, pretty straightforward. Now in our load function, we're going to do the same thing that we do for items, but for mobs. So it's basically identical. For instead of I and item, it's I and mob. We iterate over the mobs and enumerate them, and we insert their indices into that hash map so we can get them back later. And now we're going to want a spawn named mob function, which is going to be pretty similar. I don't know if it's going to be the exact same, but let's go ahead and just copy that signature. Oh, I'm looking at the wrong thing. Oh, we're making helpers, that's why. Okay, we'll forget about that for a moment. We're going to make some helpers. Because we're going to want a spawn named mob function, but first, let's make some helpers so we're sharing functionality with spawn named item. Avoid repeating ourselves. The first is going to be pretty straightforward. So spawn position, and it's going to be, well, I'm just going to type it. It's pretty short. I'm not sure why we do this one here. That one tripped me up before, why we're just setting it to another variable. Thinking it's going to be copy clone stuff. All right, so we get our X and our Y ripped out of that, and then we say EB equal EB dot width position. X and Y. And at the very end, we simply spit back EB. Very simple. Basically what we're already doing. When we add more spawn type entries, this function will necessarily expand to include them. So it's great that it's a function. Now we don't have to do it in multiple places. We can replace the same code and spawn named item with a single call to this function. Where in the world is it? So there we go. We're also going to break out the handling of renderable data. This is the tutorial here. This was more difficult. I had a terrible time getting Rust's lifetime checker to work with a system that actually added it to the entity builder. I finally settled on a function that returns the component for the caller to add. So let's take a look at that one. Should be fun. All right, I got to scroll over. Of course, it is just renderable, but making sure I'm not missing anything. When I save, it's probably going to immediately do that because that's a much better line limit. And this is the same kind of code, so let's just go ahead and plop these in here. And it still cleans things up in spawn named items, so let's go up to the renderable. So instead of all that, we do that. Much nicer, much cleaner. So now with that in hand, we'll go ahead and make spawn named mob. I was like, it should not be an entity builder, but that's what threw me off because I was like, oh, we're doing other things first. Should, however, be an option entity builder. And it's probably going to be very similar in that we're going to default to none. And we're going to start with a check. Oh, wait, first of all, new entity builder, position, spawn type. Oh, wait. Spawn named. No, it's not an entity builder. Why did I do that? Oh, I was looking at the new entity. My bad. That's better. Sorry. I am just slipping today. I was like, yeah, we just did this. So same thing as before. If it contains the key, then we get the template. Oh, that's why. There we go. I was like, I know I'm doing something wrong. So the template, we pull that out of the mobs by getting the index that we set earlier. Just indexing directly into it. Let mute EB equal new entity. Spawn the specified location is going to be spawn position. Just like that. Renderable is going to be like the same. If let sum renderable equal and mob template dot renderable. Just like that. And now we have a couple other things happening. So EB equal EB dot with monster. If mob template blocks tile. We add that component. We do combat stats, and that one's not too bad. It's a little boilerplatey. Max health is mob template dot stats dot max HP. And lastly, the view shed. Oh, I wish it would have already formatted. We give him a new vec. We give him the range, which was from what? Just vision range. And dirty, I think, should be true. Because we just made it, so we want it to read. Yeah, it should be true. And then we return that. Cool. I don't think I need to explain this. We just keep adding the components as necessary. We know that the stats and everything are going to be here, so we don't have to check for it. You know, we know the mob template here is a mob because it's just straight out of our vector of mobs. So we know what comes with it and what doesn't. That's why we have to do the if-let for renderable. But I mean, that's it. It's just the same thing we've been doing. And the tutorial basically says the same. There's really nothing we haven't already covered in this function. We simply add a renderable, apply a renderable position, name using the same code as before. Or we apply renderable position and name using the same code as before. Then we check blocks tile to see if we should add a blocks tile component, copy the stats into combat stats component. We also set up a viewshed component with vision range. Before we update spawner RS again, let's introduce a master spawning method, spawn named entity. The reasoning behind this is that the spawn system doesn't actually know or care if an entity is an item, mob, or anything else. Rather than push a lot of if checks into it, we'll provide a single interface. Scrolled over at some point, but I'm not typing that. Why? Because I don't want to scroll back and forth. You just saw me do there just to read the whole line. So we'll go up to the top here before spawn named item or entity. Doesn't matter, but we'll do it. See that formatting's so much better. And now spawn named entity, what will it do? If raws.item index.contains key. Return spawn named item raws new entity key position. Else if raws.mob index.contains key. And there we have it. So over in spawner.rs, we can use the generic code. So instead of the item result and everything, we're going to do spawn result. And once again, their line is way too long for my taste. So I'm not even going to try to type it because I don't want to scroll back and forth. It's the same thing though, as what we're doing now. It's just we're now using the generic one. And instead of item result, we do spawn result, return, and we're good to go. We can also go ahead and delete the references to orcs and goblins. And we're done. We have data-driven monsters now, basically. Or no, we do, but now we're going to do the traps and stuff. So yeah, let's go ahead and try it. This is the one we don't need anymore, right? This monster function is also unused. Spawner is getting a lot smaller here. We're barely doing any work in here. Let's run it. Let's see us fighting a monster and make sure that we're good. And then we'll do doors and traps, and that will be it. There are 39 patterns. Okay, see, that's where wave function collapse just falls apart. That was terrible. Nothing spawned except for the stairs. That's not a spawn, really. That's part of the map generation. This, on the other hand, is way more interesting already. However, no enemies yet. It is possible, and it does happen. Got a trap. It does happen sometimes where we go through, early on in the first level like this, we go through a lot of map without seeing an enemy. Because remember, the enemies get more likely to spawn there we go. The further we go. The deeper the dungeon, the more likely they are to spawn. That was a goblin. There's a couple goblins. I'm going to assume the orcs are working as well. Because I don't seem to be seeing one yet. Unfortunately, there's just, I don't know. So many places they could be. Randomness. Do they even spawn yet? They might not spawn for another floor. Whatever, we're good. Let's go. Okay, so now for doors and traps. 2 remaining hard-coded entities. These have been left separate because they aren't really the same as the other types. They're what I call props, level features. You can't pick them up, but they're an integral part of the level. So in spawns.json, we'll add and we'll define some props. So we'll have a third array or list or whatever you want to call it here in spawns.json. And it's basically what we've already seen. We have the relevant pieces, like nothing's new here, right? And this is where it might get interesting. I haven't read it yet, but the problem with props is that they can be really quite varied, so we end up with a lot of optional stuff in the definition. I'd rather have a complex definition on the Rust side than on the JSON side to reduce the sheer volume of typing when we have a lot of props. So we wind up making something reasonably expressive in JSON and do a lot of work to make it function in Rust. So we'll make a new file, prop structs, and put our serialization classes into it. Yeah, that makes sense. So what we're saying is that We can see right here, maybe it's not renderable, maybe it's hidden, maybe it blocks tiles or visibility, you know. I get it. I'm probably gonna just do some copying here because it's all the same code. For the sake of the tutorial, I don't think I need to type every single one out, but it's gonna be pretty straightforward, I think. So let's go ahead and just get the basic data and stuff going here in prop struct, and then we'll figure it out. So we get all that, and we're going to want to go to mod and use it. Alrighty, now we'll extend raws to hold them. That makes sense. So then down here, here we go. And I'm going to guess that we're doing the same thing with the prop index. We are. We're probably going to do the same with this for loop. So bring another one in. Same thing as before. Nothing new. We're just a different name on everything, right? We're looping over props. We're calling it prop. We're inserting into prop index. Now we're going to do spawn named prop. All right, let's see that. So same thing, raw master. Raw's new entity key and position, same thing. Nothing unique there. We're gonna do the same check as before. We're gonna do a lot of boilerplate that we've done in the other ones. So nothing's different, right? We look for the thing in the props. We get it out. We call it a prop template. We do the spawn position. We do the renderable stuff. We set the name. And what I'm going to do down here is say return some eb.build. That way it'll stop complaining about that being unused as I'm going through this. Now we're going to have each one of these. I'll do this one. Let sum hidden equal prop template dot hidden. If hidden eb equal eb dot width hidden. Remember that hidden value there is a Boolean. It looks odd saying if let sum hidden and then if hidden, but it's a Boolean, right? So it looks weird in that case. Blocks tile and visibility are going to be the same. Door open is also going to be the same, basically. Well, door open's a little different, I guess. But the other are going to be like the exact same. If blocks tile, if blocks visibility. Door open is basically the same thing, except it's not a Boolean check because we don't currently have a way to like close doors and stuff. So, if there's the door open component, then we just go ahead and do this. Oh, wait a minute. Hang on. No, I was like, wait a minute. That's not right. Oh, right. No, it's because the value. Yeah, that's it. Sorry. It is true we don't currently have a way to open and close them, but no, it's because we're passing it into the door. I was just looking at the lack of the if statement and forgetting what I did a few days ago. So we're lacking, we're not passing these other ones, blocks visibility or tile or hidden, because the components are the only things that dictate what happens. In the case of the door, whether it's open or not is actually stored within the component because you could potentially change that. That's it. Okay. Now this one's a bit beefier. The entry trigger. I wonder why we took a reference to it. We will see what happens. We'll add the entry trigger component. And we'll start looping over the effects here. Entry trigger.effects.iter. And then we'll match them. And we have damage and single activation. If it's damage, we do an inflicts damage component. This is all just what we already spawn on them anyway, right? One moment. Okay, sorry. This is what we're already spawning on them anyway, right? There's nothing new here really being added. If it's got the trigger stuff, then we need the inflicts damage and the single activation. Pretty straightforward. We have to parse out the data there because it's a number. We don't know what the number is going to be. So you can make different traps with different values and stuff. The tutorial actually also says, and I quote, "We'll gloss over the contents because it's basically the same as what we've done before. We need to extend spawn named entity to include props. I'm going to trust that you trust me that I'm doing that." You literally just saw me copy it. So there we go. That's done. And finally, we can go into spawner.rs and remove the door and bear trap functions. We can finish cleaning up the spawn entity function. We're also going to add a warning in case you try to spawn something we don't know about. So we'll do that. And we're at the wrap up. It's really good stuff. So go delete that. Oh my God. Fat fingering everything. Why is that still here? I thought I got rid of that. I know it came back once, but I guess I did a second. Yeah, when we changed it to named entity instead of item. Named entity instead of named item. Let's see. I think everything else is basically the same. The map, the width, the X, the Y, memdrop, spawn result, spawn named entity. I don't think any of that's going to change. So now we can get rid of bear traps and doors. Like we just added doors, I think last time, and they're gone now. Or maybe the time before, whatever it was. Cool. This thing is nice and simple. A lot of things here are no longer being used. Oh, that doesn't work? Damn. I was hoping it would just get rid of the extra commas for me. Our imports there got a lot cleaner too. Gotta love it. Uh-oh, someone's mad. I got rid of too much. Can't find map? How did I get rid of map? Let's not do it that way. Let's do map in here. I guess I just got one too many things. Okay, we're good. We're no longer red. And we've cleaned everything up. Doors and traps should be working. So let's give it a go. I'm moving my browser around and stuff while I'm letting it compile, letting it build. Where am I? I got a bad spawn. That hasn't happened in a long time, and I think it had nothing to do with the spawn changes we just made, incidentally. There are still some problems that we run into from time to time. This is not perfect, and I've called out some problems in the past. See, we're good now. That looked different. The color of the door looks different to me. Was it changed? Oh, we got a trap. And it works. It hurt me. I feel like the door was really hard to see. It used to be brighter. Something. I don't know. Either way, we're good. It works. So the thing is, we still have loot tables. Everything else was not changed. Okay, I'm trying to get to spawner. Everything else was the same. We still have the loot tables being managed and maintained the way they are. Like we see the stuff here. What's happening that's different is when we go to spawn something in here, we have the name of it and everything. So we're able to basically match against that name. We're kind of, right? Yeah, because that's our key. The name is our key. So we're saying key is goblin. So then we're looking through the raws for something called goblin, right? There is a flaw that I can think of right now, and that is right here, spawn named entity. What if goblin can be an item and a mob? That might sound strange, but what if it could? What if you had like a figurine of a goblin, but it was just called goblin? Right? Or I was going to say like a corpse, but you'd probably call it goblin corpse or something. But there's a flaw here, basically, that it's going to look for the item first, and then if it's not an item, it's going to go to mobs. If it's not a mob, it's going to go to prop. What if you could have a door in your inventory? Then that would be an item door that would not be a prop, right? I know that sounds weird, but I see that as a flaw. What are we don't know how to spawn none. What are we passing in that's a none? All this is fine. Something in our loot table or something. All these should be accounted for, though. We've seen most of these things spawning. Where would a nun be getting added to our spawn thing? Spawn entity, it's called here. Our spawn list. There's too many places we use spawn list, isn't there? That's something I'll consider looking into, but I don't think it's actually an issue. You know what I'm thinking it might be? Spawn list. Do we reset it? We do. We do spawn list.clear. And it's specifically on wave function collapse. What if we get one that's not a wave function collapse? This one's not, and we're still getting it. So we might get it in other cases as well. Spawn list.clear. Or spawn list.retain. Apply previous iteration in the prefab builder. So what I'm noting is what we're doing is we're building out a spawn list, and then if we're clearing it, we're actually keeping the same spawn list, but it's... No, that wouldn't be nuns. Never mind. It's not... It wouldn't be nuns. It would... I was thinking we'd still have it allocated, but no, that's not going to happen. Spawn list.push. There's only a few places we do that. Put doors in there. Doors are working. So I'm going to ignore that one. Prefab builder, putting these things in. The only other place it happens is here. Right? So spawn region. Spawn region has the spawn list. It's pushing things into the spawn list. And what is spawn? It's from spawn points. Spawn points insert something from the spawn table dot roll, and we get a none. Oh, right. We don't know how to spawn none because there is a chance that we don't do a spawn, right? Our roll, while it's greater than 0, if the total weight is 0, we return none. And then if the roll is that thing, we return the thing. So returning none is actually defined behavior here. It's not anything weird. You know, it's been so long since we've done this, it's good to refresh a little bit. All right. Just weird to see in that moment. This chapter has given us the ability to easily change the items, mobs, and props that adorn our levels. We haven't touched adding more yet, or adjusting the spawn tables. That'll be the next chapter. You can quickly change the character of the game now. Want goblins to be weaker? Lower their stats? Want them to have better eyesight than orcs? Adjust their vision range. That's the primary benefit of a data-driven approach. You can quickly make changes without having to dive into the source code. The engine becomes responsible for simulating the world, and the data becomes responsible for describing the world. And that's that. Now, this chapter looks a bit short-ish. I'm going to skim it real quick to see if I want to do it today. So we have our room table. This is stuff we already know about. We want to do a JSON-based one, where we'll have a name and a weight and a min and max depth. It's all the same data that we're really using here. Yeah. So here it is. We've add map depth to weight to allow us to indicate that things become more probable later on in the game. Let's do this. It won't take very long. Let's do this one today. It's like I'm hungry, but let's go ahead and do it. That way we can focus on making a town and stuff next time instead of splitting the logic next time. So in the previous chapter, we moved spawning to be data-driven. You define the monsters, items, and props in a JSON data file, and the spawn function becomes a parser that builds components based on your definitions. That gets you halfway to a data-driven world. If you look at the ever-shrinking spawner.rs, we have a hard-coded table for handling spawning. It's served us well for all these chapters, but sadly it's time to put it out to pasture. We'd like to be able to specify the spawn table in our JSON data. That way we can add new entities to the data file and spawn list. And they appear in the game with no additional Rust coding unless they need new features, in which case it's time to extend the engine. A JSON-based spawn table. Here's an example of how I'm envisioning our spawn table, and basically what I just looked at. A name, a weight, min, and max depth. So the spawn table is an array with each entry containing something that can be spawned. We're storing the name of the spawnable. We give it a weight, which corresponds to the same field in our current random table structure, and we add a min and max depth so that the spawn line will only apply to a specified depth range of the dungeon. Looks pretty good, so let's put all of our entities in. And I guess we're just putting that in our current JSON file? Yeah, because it's going into the spawn. Okay, it's going into the original raws that we've been using. So let's head on over there real quick to our JSON, spawns.json. And we'll just put a little blop right there. And it's all of our usual stuff. Again, no need for me to type all that out. It's very boring. What I would probably be doing if I were doing this myself, I would copy what we have in our Rust code over here, wherever it's at, in Spawner. I would find the table, I would copy this, and I would try to do multi-line edits to make as much of it change at the same rate as, you know, to make it as similar as I can as quickly as possible, but we're not going to do that. It's a waste of time here. So we've added this add map depth to weight. Where? Oh no, it's in the, okay, let's go back to it real quick. Add map depth to weight. So then some of these are affected by map depth, some of them are not. To indicate things become more probable later on in the game. That'll let us keep the variable weighting capability. We also put longsword and tower shield only occurring after the first level. I'll take their word for it. Min depth 1, yeah, because we start at 0. That's pretty comprehensive, covers everything we have so far, and adds some capability. So let's make a new file, spawn table structs. It's going to be about the same thing we've been doing all today. And let's head on over to the mod here. Oh, whoops. I mean, I guess I could have done that anyway. So the first thing is we're going to, well, We'll just add this here for now. Spawn table entry. We don't have one yet, but we'll just put that here. And then spawn table struct, copy in the boilerplate here. Serialize, deserialize, renderable. Renderable does not need to be there. I don't know why it was there. It's probably a typo on the tutorial, but it's everything we literally just saw, right? We're defining the JSON, right? So we have name, weight, min depth, max depth, and add map depth to weight. That's the only optional thing too, so it's going to be really easy. So now we'll go to the one that's going to be mad, which is raw master, and we're going to need the we need to do, oh wait, is this, what's in here? Oh right, no, this is what I need. Yeah. So let's see. All right, so we're taking our spawn table, which is just a vector of that spawn table entry. Each one's an entry. We just list them all out, basically. And that's it for the moment. It's worth doing a quick cargo run now, just to be sure it's loading properly. It won't do anything, but it's always good to know the data loads. Yeah, we'll get a nice crash if it doesn't. Well, should be good if we made it this far. All right, next up, using the new spawn table. So in raw master, we're going to add a new function to build a random spawn table from our JSON data. Just going to slide all the way down here to the bottom. We need the random table, which showed up from where? It just showed up. There we go. And we'll return an RT, which has to be a random table. All right, before we actually do that, I just want to make everything happy. We're going to get our available options. Spawn table entry equal raws dot spawn table dot iter dot filter dot collect. Okay, so we are passing in our depth, right? And we want to build the spawn table based on that. So we filter out everything based on our depth, right? So A is our current spawn table entry. And we want to say A is greater or equal to the min depth. Or we want to say depth is greater or equal to our current entry's min depth and less equal to our current entry's max depth, A being our current entry. What I'd probably rather do is spawn table entry. Makes it larger, takes up more room, but it's more clear now because depth is what we passed in and A was just an arbitrary thing. We're collecting that into a vector. So now available options is all the valid things that we can actually spawn based on our depth, right? So we'll make the random table and then we will iterate for E in available options dot iter. We'll get the weight. Why are we doing that? That's why, because we're modifying the weight. Okay, so let's take a look at it. We get the starting weight out of... Okay, this is what's bothering me. The E is bothering me. Available entry. That to me is so much better. I don't know what E means, right? I know what available entry means. So for available entry and available options, we get the weight out of it. If available entry.add map depth to weight is sum, then we literally add that. And then after we're done with that, in either case, we add it to the random table. We clone the name and we just bring the weight in. Very, very, very simple. And the text also says that. I always say that and then I look over and I start reading the text and I'm like, oh yeah, it also says simple. The function is quite simple. We obtain the raws.spawn table, which is the master spawn table list. We obtain an iterator with iter. We use filter to only include items that are within the requested map depths range. We collect it into a vector of references to spawn table entry lines. We iterate all of the collected available options. We grab the weight. If the entry has an add map depth to weight requirement, we add that depth to the entry's weight. We add it to our random table. Let me check one thing. So all we care about is if it exists. We don't even check the value, which I think is an oversight. It is a Boolean. But if like we're reading this, if add map depth to weight is sum, it just adds it. I'm calling that a bug right now. And I'm going to say if let add map depth to weight equal available entry dot add map depth to weight. If add map depth oh, I didn't do the sum. There we go. I was like, what am I doing? If add map depth to weight, then weight plus equal depth. It's a little bit longer, but that's probably what we should be doing. If you disagree, feel free, but why did we make it a Boolean? We're not checking. If you put false, it would still work because the field exists. All we were checking was is sum, meaning the field exists. It could be sum, but it could still be a false value, right? So I'm calling that a bug that we just fixed, even though we haven't ran it. So anyway, we did the filter. Then we collect the filtered stuff. We iterate all the collected available options. We grab the weight. If it has that requirement, and in my case, if it's true, not just if it has the requirement, we would have had to define like a tag struct and just say, oh, that one exists, but it's not defined like that. It's, again, defined as a Boolean. And then we add it to the random table. Yeah, I would just hate to see someone put false on that and they're getting the wrong behavior. Ooh, hold on. Okay. So then we can open up Spawner, modify our room table to use it. Let's go do that. Room table, none of this matters anymore. Boom. And now, if we cargo run, we get the same game as before. So what I do is I hit this, and while I'm waiting on it, I get my browser, I put it back on my main monitor. I click back into VS Code, so I'm looking at it now, and now I wait for the compile, and boom. I kind of like when this happens. It looks cool. Sometimes I feel like it's a little bit much, and it's random, but the way it digs straight out sometimes, I would almost like it to be a little bit more guided. And dude, we're doing everything this time. I'd almost like it to be a little bit more guided in that what I'd kind of like to see is if you have a square room, it does a little bit on like erosion around the entire room. Kind of like the rounded stuff, but more Drunkard's Walk looking. Is that our stairs? Really? Yep. Alrighty. Wait. I didn't see any spawns. Did I? There's some spawns. Some of the spawns don't count because they're part of the prefab thing. All right, we're getting stuff. Well, the doors are a part of it too, though. Doors are in the loot table, or the random table as well. No, they're not. Never mind, I'm stupid. They're not. But the other stuff was. We got a scroll. Where's that? In here? No, in Raw Master. Yep. And then we'll check the JSON real quick. Yeah, we got a scroll and stuff. I think we're good. Goblins and orcs and stuff. Run it one more time. Oh, come on. I still should fix that. Give me a fast one. Or I should go turn the variable off so we don't have to watch the maps. I could have already had a map at this rate. We are wave function collapsing this? Yeah. So we're doing everything this time. We're going to dig the map out a little bit, and we're going to wave function collapse it. I can tell by the console. You can barely see it, but you see there are 240. Reduplication, there are 240 patterns, and then it says there are 50 patterns. Yeah, some of that's piecing together really satisfyingly. Hope we don't get a jacked up map now. It spawns me in a corner where I can't reach anything. You know, it literally did. It literally did. Because I was going to be like, if the stairs are here, that's because that's the furthest spot. Dude, why does that break so often? Constraints are not great. Alright, we're getting potions and stuff. Yo, a nice big old room there too. Look at that. What is that? The shield? Yeah. What is going on, Tusk? How you doing? I'm about to wrap up here in a few minutes. Almost done. So we're going to add some sanity checks. We've now got the ability to add entities without touching the Rust code. Before we explore that, let's look at adding some sanity checking to the system to help avoid mistakes. We simply change the load function in Raw Master. I'm not going to talk about that here. That's all I'm going to say. That's not for coding streams. All right, so we do raws, we do the item index. Let mute used names. I have an interesting criticism that I think I would do if I write something like this. I would like to almost explain what you're going to do before you do it. Why did we make use names? We can infer, we can make some reasonable guesses as to what we're going to do with it, especially with a name like used names. But I just write this and I'm sitting here like, I don't know. I don't know why I'm doing it yet. I don't have all the context. It would be great to have a high level overview of what kind of sanity checks would be useful. You know, the text says we're going to add some sanity checks to avoid mistakes. Well, what kind of mistakes are there to avoid? What are some tactics we can use to avoid them? And then let's implement them and then also break down the code. I think that would be a better way to do it. Because now I have to also look through, and every single one may have differences now, and they actually do, but it's a pain as well. It would be helpful to know a little bit more ahead of time. So for I item, self raws items, iter enumerate, and this is going to get bulky. If used items dot contains item dot name, I don't want to type that. Colon hash set. Because we're going to do this for all of them. Oh, not used items. Use names. And then this is going to be prop, and this is going to be mob. I never knew that was supposed to be movable object. I never really liked the word mob. The first time I heard people using it was Minecraft. And I never really liked it. I thought it sounded weird. I thought it sounded lazy. So then in each one of these, I was like, they're enemies. They're bad guys. I like enemy, but you can call them like bad guys or whatever. Creatures, I don't know. I just thought it sounded strange. And then all of a sudden, like, everyone's calling things mobs out of nowhere. As far from my perspective, I'd never heard it, and then all of a sudden, it's everywhere. So to me, I associate it with Minecraft. That's the first time I heard it. And I was like, why did Minecraft do this? Okay, so each one of these, we don't really change the basic logic we had in, but we're saying if it already has used that thing before, as we're populating and like loading things up, then we put a warning. Next, down here for spawn in self.raws.spawnTable.iter, if not used names.contains spawn.name. And I don't feel like typing out the warning because I have to scroll the damn thing to read it. Warning: spawn tables references unspecified entity blah. And there we go. So the text says, well, what are we doing here? We create used names as a hash set. Whenever we load something, we add it to the set. If it already exists, then we've made a duplicate and bad things will happen. So we warn the user. Then we iterate the spawn table, and if we've referenced an entity name that hasn't been defined, we again warn the user. These types of data entry bugs are common and won't actually crash the program. The sanity check ensures that we are at least warned about it before we proceed, thinking that all is well. If you're paranoid when programming, that's actually a good trait. There are plenty of people who are out to get you. You could replace the print line with panic and crash instead of just reminding the user you may not want to do that if you like to cargo run off and to see how you're doing. Benefiting from our data-driven architecture. We're here right at the very end. Let's quickly add a new weapon and new monster to the game. We can do this without touching the Rust code, other than to recompile, embedding the changed file. In spawns.json, let's add a battle axe to the weapons list. I think it'd be cool to maybe move away from the WebAssembly and do it more properly. I know they're doing the workaround for the WebAssembly, but it'd be nice to do that. So I'm going to just go ahead and compile real quick, get things running, and then we're going to add that new stuff. Tusk says, my nose is running like crazy. Maybe I should catch it. Dude, you weren't here at the start of the stream. I don't know. Something just died. Like, my nose went crazy. I was sneezing a bunch. It was ridiculous. We just compiled there. We're not going to touch any Rust. We're going to go to the spawn table. We're going to go to our weapons, which is just an item. We're going to add a battle axe. So we'll just put it up near the longsword and stuff. So it does 5 damage. It's stronger than the others. We're also going to add it to the spawn table. So we'll go down to our spawn table down here. It can appear min depth of 2. It has a weight of 1, so it's somewhat uncommon, but not too bad. We're also going to add a humble kobold. It's basically an even weaker goblin. We like kobolds. Let's have lots of them. Okay. We're going to add it to the spawn list first, because I'm already down here. So we'll say right before goblin even, we'll add the kobold. Weight of 15 versus the 10 goblin. And oh yeah, orcs are really, they're a weight of 1, so they're going to be pretty uncommon too. So yeah, kobolds are going to appear a lot more than goblins. And let's go ahead and add their information in our mob list. And we'll add them first since they are weaker. And their glyph is going to be a K. They're going to block tiles. They have 4 health and 0 defense and 2 power. So no defense at all compared to even an orc having 1 defense, a goblin having 1 defense. They have 3 and 4 power. This thing only has 2 power, and it has only 4 health. Half of that, half that of the goblin. So very, very weak. And we made them really common. And then after level 3, because of the spawn table, max depth is 3. So they will not spawn after level 3. If we cargo run, we'll find them in the game. And that's going to be it for spawn tables. So let's click back over. Let me get this thing. I should have started compiling first. It does have to embed the file, but I don't know how long it takes. It's still taking a little bit. Yeah, all I touched was a JSON here. I didn't touch any Rust. This is pretty good stuff. All right. So let's see if we got a terrible wave function collapse this time. Hey, so far it's okay. No kobolds or anything, though. Lots of different items are showing up. That's a good indication that things are working, I would argue. No enemies whatsoever. If we do find an enemy, we should reasonably expect it to be a kobold. Given that they are weighted more than anything else. And of course it was a goblin. There's a kobold. Look at that. Just like that. No Rust code needed to make that happen now. We could add anything we wanted by just typing that JSON. Now, if I wanted to go through a couple more floors here, we could actually see that the kobolds will stop spawning. I don't think I'm going to go through that right now because, well, we've been going for 3 hours, and I'm going to be back on stream here in a few hours to make up for the lack of... Wait, we got a broken spawn. Dude, this is not me, by the way. This is not my code that's doing this. This is the tutorials code. I didn't change any of the... I literally had full copy of everything. Anything that I did change did not change the functionality. It was a different syntax to do the same thing. And you could argue, well, maybe you made a mistake. Not in those cases. Those cases were too simple to do that. Or it was a case where Rust would not have allowed me to do that. Like the if let versus let else. Still accessing the same data, just in a slightly different way. Well, that sucks. But occasionally we get those bad spawns on the maps. Hopefully that it gets addressed. Because I have some ideas. If we're going to make maps navigable both up and down, that's going to help as well. Okay, but that's it. Bit of an anticlimactic ending there, but we did get new things showing up, which is good. That's what we wanted. So that's it for spawn tables. You gain considerable power in these last 2 chapters. Use it wisely. You can add in all manner of entities without having to write a line of Rust now, and could easily start to shape the game to what you want. In the next chapter, we'll begin doing just that. So next time, we're going to look into making a town. And if we go way down here, we could see a lot of cool stuff happening. A little water or something over there, some grass, built like walls maybe, a little road running through the middle. Some buildings are showing up there, and the buildings are going to have entrances now. Little roads between the buildings and between the main road. And then we can walk around that little town that we build. That's going to happen on Wednesday. I'm really excited for that. This is one of the reasons I was so excited about doing this tutorial, was seeing things like this from the beginning. That and just all the map generation stuff. So really cool. We're going to do that next time. That's it for today. So thank you to anyone who showed up today, whether you are lurking or chatting. I do appreciate it. I think it's a pretty good session today. I like the whole data-driven stuff. That's something I was excited about. I'm not excited about the way we're doing it, which still requires us to recompile by embedding it into the executable. I would like to read it at runtime, which we technically do, but I'm not running WebAssembly, right? I don't really care about that for my use case. So I would like, it would save a lot of time by not baking it into the executable. It would save a lot of time every time I run the game. I wouldn't have to compile it. So it is what it is. I think that would be an interesting way to ship your game, is like if you don't provide the raw files, it's already baked into the executable. But then if the raw files are there, you can modify them. It'd be an interesting way to do it. It'd be a beefier executable, but whatever. So anyway, that's it though. Thank you to anyone, if you like this kind of stuff, if you like these coding streams, you could definitely hit that follow button. I do gaming streams as well, of course. I do Genshin Impact once a week, usually on Sunday. We're doing it here in about 3 hours today because I didn't do it last night. I wasn't feeling the best. I was too tired and kind of meh. I'm doing the whole Metal Gear Solid franchise right now. I do Dwarf Fortress. I do Caves of Cud. These are the current things I have going on. So if any of that is interesting to you, you can hit that follow button and come hang out. Next up is you could also go over to YouTube, or where these streams go live 2 weeks after they are here on Twitch. And I feel like that's a weird way to say it. Why am I so off today? You can also go over to YouTube, where these streams go up as videos after they're 2 weeks after they're live here on Twitch, and do all the fun stuff while you're there. And by the way, if you are watching this in the future on YouTube, congrats on being in the future. I would appreciate if you'd like, subscribe, hit that notification bell, leave a comment. I do read and respond to comments there. Lastly, you can follow me on Twitter and see my tweets when I go live, and that's most of what I do on there. The occasional other thing, but not too much. That way, if Twitch notifications are delayed for you, you'll see when I actually go live. So that is it for that. Like I said, I'll be back in about 2 hours and 50 minutes, about 3 hours from now. So if you're watching at the moment, I will be back in about 3 hours for Genshin. We'll do that for 3 to 4 hours, do a little bit of exploration and stuff, have a good time. So that's going to be that. Until next time when we make the town, have a good day, have a good night, whatever it is, wherever you're at, take it easy.
A dud!